Right. Hi, everyone, and welcome back to the eighth session in NMRA's Systematic Review and Meta-Analysis series. Joining us again today, we have Dr. Connor Gillespie, who's here to do the second part on a series of how to conduct a meta-analysis. Dr. Connor Gillespie is a FY2 doctor at Cambridge, and he graduated medical school from the University of Liverpool with an honours, and also obtained an intercalated degree in surgery and oncology. He's the former chair of Neurology and Neurosurgery Interest Group and will also be starting a neurosurgery ACF in Cambridge in August. He's published extensively in multiple high impact peer reviewed journals and is passionate about teaching and inspiring the next generation. So I'm just going to hand over to Connor now.
Thank you. Thanks. So I'll hopefully make this one quick, guys. Should just be a practical session, really. So I'm going to demonstrate just how you can carry out the meta-analysis that we did in the theory. I think, to be honest, this will be about 10 to 15 minutes. I'm just going to kind of show you guys how you translate the knowledge that you guys have into actually doing a meta-analysis. It's a bit, I'll just show you two methods very quickly, or two software programs, and it's going to focus on the comparative outcomes that we mentioned before, as in, is the outcome a yes or a no, such as, has death occurred, yes, has death occurred, no. And then we'll just look at two different software programs that you could use to do your meta-analysis, probably the two most popular ones. So we'll just get started and take you through. Let's try to share the screen. So we'll just be going on my screen for this. So it'll be, there's no PowerPoint slides or anything. It's just sort of taking you through how you would physically convert your study into a meta-analysis. Right. Okay. All right, so can you guys see my screen okay?
Yeah, that's perfect.
Cool. So essentially, this is the first program. So there'll be two programs that I'd recommend you use for your meta-analysis calculation. One is going to be Cochrane RevMan, and the other one is going to be in R. Cochrane RevMan is where everyone starts out, so I'd recommend you use this tool. Unfortunately, they have recently switched it from a program, like a user extension, to this web page, which I think is really poorly designed, but we'll have to make do. I'll just show you the example that they have provided, which is sort of looking at inhaled corticosteroids for asthma, and they're essentially looking at different doses of corticosteroids and its effect on asthma, and using, as we said, dichotomous outcomes, so like yes or no. Okay, so more or less assuming you can start off from the get-go, what you'd have to do, let's say if you've got this as a blank review, all you'd have to do is to get, essentially this is where they end up. So I'll show you where we need to end up, more or less. Let's have a look. Analysis. So essentially, here is where they ended up, and here is where we want to end up. So with a completed forest plot and meta-analysis conducted. You'll start with 0 on all these, so it's not very representative. But essentially for this, and to work this out, you don't have to do the full review in RevMan. You just have to put in the data that's important here. So looking at how you do it, you need a few things. So you need to, in RevMan, you need to manually upload your studies. So you need to essentially have the study to hand and then use it. So taking you back to kind of the data set that we maybe had, I'll just show you in this program kind of the data that we would have. So essentially in this top left-hand corner, this is in R. So we'll look at R just after this, but more or less we're going to be using, a database of a number of patients. So in this study, this is like the number of patients who had an intraoperative MRI. And this is the number of patients who had a complication after their operation. And then this is people who had the standard treatments and then had some complications. So it's very similar. So you just have the number of participants in total and the number that experienced the event. And then translating that into this one, you can see that their event is Their event is treatment failure, which is defined as a need for systemic corticosteroids, and they have two groups. One is a group who has an increased dose of inhaled corticosteroids, and one group is continuing on the same dose. They've got the study, they've got the number of total participants here, and they've got the events in each group. They also include some groups with 0 events, which they are, I guess, able to do. And at the end, they have a result here. So essentially, to get to here, all you have to do is navigate to your, even if this is blank, you can just name it whatever you need to. You can go to your studies tab, and then for RevMan, you have to manually upload each of these studies and this data. So if you go on included, if you wanted to just include, you'd add a study. So let's say if you wanted to add one, so let's call it new study 2. Let's say it was 2023. And then essentially you'd add your references. So this could be the PubMed ID or the PubMed link, so the journal article. You could just add in pages and stuff. It is not essential for the meta-analysis, but if you're doing a whole review in RevMan, I recommend it. Your characteristics, this is just for your method section of your paper, so not really important. Covariate, again, I wouldn't worry about these for now. Your study arm, you can add these a bit later, or essentially what you more or less add. Your study arm, so you can add an arm, and then an intervention usually will pop up, which you have to fill this in at the start. So at the start, it'll ask you what your intervention is. So if you have 2 groups, you have to fill them out at the start, and then it will let you pick one. So say if I said, these are the groups that you're going to compare. So let's say if I said, the stable dose, and then I added another arm because I wanted to have 2 groups, one group staying the same that I had data for, and one group that doubled their dose of inhaled corticosteroids. You have to add those on. And after that, you have to essentially add you can add a result. Again, this comes from what you define at the start. So more or less I would add treatment failure, so need for systemic corticosteroids. Again, you'll define you can add these as outcomes in your study. So you can just add them using the tool. Okay. And now you've got both groups, and you can just describe the events in the total. So let's say if in new study 2, I have 10 events and I have 100 people. And in the stable group, I have 20 events and I have 200 people. And I have maybe, 60 people. And then in theory, this should crop up here. And then if you go back to your analysis, I'm hoping that when you click on this, it comes up. It might just need to be refreshed, but essentially that's how you add each study, and then it will pretty much just pop up here and give you a nice result. This is quite a sophisticated analysis, so essentially it produces the same forest plot as we described before. Most of the time, you'll be able to kind of edit the analysis and describe what you want. So you can kind of change your filters and your effect model. So for me, the most important thing at this point would be to keep most of it the exact same, but then just maybe think about, as we described before, changing maybe the fixed effects to a random effect. And then I think once we get past that, let's go back to the analysis. And you can see that it changes the results just a little bit. But more or less, I don't really like this new RevMan Cochrane that they've done. I don't really think it's a good system. It used to be very interactive and very helpful, and I think this one is kind of just very confusing. So more or less, there is a Cochrane handbook that has a guide as to how you can input each data. I'm still figuring out myself, but more or less it's quite easy. You just upload the studies, fill in the results data, and it will automatically generate a plot like this or like this one. So that's more or less Cochrane. It's just a case of looking through the handbook that they provide and going from there. If we then look at RStudio, so this is the program that I said I wasn't going to recommend, but I think if people are really keen to try, it's meta-analysis is a good way to get into coding, and this is for people who either don't enjoy RevMan or find it difficult, which I did. So RStudio is a bit different. Essentially, people might be familiar with it, but it involves coding rather than clicking. So I think RevMan, it's based on like a user interface. You click different buttons and different stuff pops up, and so you kind of code that way. RStudio, you have to manually type in your code. So it looks a little bit like the diagram on the top left-hand side. Makes it quite difficult. It's got a steep learning curve, but I think it's pretty good for doing meta-analysis, really. It allows you to customize your graph, customize your surgical, like your sort of technique that you use in your analysis. So I kind of show it to people just as a, this is how simple it is, really. It doesn't need sophisticated coding, and you can actually give it a crack yourself, and most of the time ChatGPT can generate the code for you. So essentially in RStudio, once you figure out how to use it, you need three things to use it. You need packages. So these are software packages that understand how to generate graphs and what you want to do. You need to have a data set, and you need to have code telling the software packages what to generate and where. So this is for someone called Gideon, one of my friends that I helped on one of his projects for. So you have a few, essentially these are all Googleable. Like if you just Google meta-analysis in RStudio packages, it will recommend these, and you more or less just run them on your setting. Then what you have to do is you have to import your own data set, so and then attach it, this is what it is. So if you have a database on your computer, this is kind of what ours looks like. This is just the number of, just like that Excel spreadsheet that we showed you in the last video or session, just has the groups and the number in each. So again, this is intra-op MRI, number of people. This is the number of complications. And this is the people who didn't have intra-op MRI and their complication rates. And it's on an Excel file. So you can pretty much, you click it, you import it. You can import it from Excel or from SPSS or wherever, but I often just use what I'm used to. And if you find the work, it should be, I think it's this one. If you click on it, it should pretty much import it. You can go back and you can attach it. Nice and easy. Actually, one sec. This one. I think it's this one, actually. Okay. Then once you've got that data set attached in the packages, all you need is the code. So this looks quite frightening, but I'll just dissect it down for you and what each one means. Essentially, you can get this code from just Google. It's really not hard. If you just type in meta-analysis of binary outcomes RStudio, even ChatGPT can generate it for you. Essentially, what this is you have, that's great. So in this group, you have, this is saying do a meta-analysis of binary outcomes. Again, you don't have to remember this, that you can all copy this. So do a meta-analysis, my events.e, so this is my number of events in the experimental group. So I can just have a look. So this is my experimental group, the group that had intraoperative MRI, because this is my sort of intervention. And this is how many developed a complication. So that's going to be my event group, so IO MRI complications. My NE is number in experimental group, so like the number in your intervention group. So that's IO MRI, which is this one here. Your stud lab, which is your study label, so which we have here, which is called author and year, just in no spaces. So it's author and year. Your data, so this is what we've defined before as Gideon metacomps files. So that's just saying with the code, use this data set. Your SM, this is your sort of standard measure. So it's an odds ratio. This is the exact same as the Cochrane tool, which I think is, I'll just show you. This is the Cochrane default. And you can see this is an odds ratio that they're using. So you could change this depending on what you want, but in most cases you'd use an odds ratio. You can always use a hazard ratio or like a standardized mean difference, but for now just stick to basics. Your method is MH, so just ignore that. That's a stats one. MH exact, again, that's a stats question. Just keep it on the default. And then you can see in R, you can kind of modify which model you're testing. So we talked about fixed and random effects meta-analysis in the past. We talked about fixed effects and random. So I've said don't do fixed effects, just do the random effects model. And then this bit as well is just all stats that you can keep the same. So obviously it's a steep learning curve, but let's say you've managed to figure your way around it and you have a blue line, which means the code works. Let's say you can just do something called a summary. You can type in summary and then of what you've said it's called, so m.bin, and it will essentially generate for you some written information about the odds ratios, number of studies, number of observations, number of events, the random effects odds ratio, the 95% confidence interval, and the p-value that you're going to use. So that's quite nice to have it in writing, but I think obviously we're here for the forest plot. So with R, it's not very hard again. You just can find code that you can use online. So most of it's on you can get it from a Google search, but essentially you just can use something called forest. Literally just copy paste. I copied this from the internet, and you just replace their sort of labels with your custom ones. So all these are relating to my study labels and these definitions, okay? So if you just grab this and type it, in theory it should give you, it gives you this forest plot here, and I'll just show you that I'll remove the plot so you can see that it works. Yeah, so you can see it generates a plot here. And this one gives you the exact same thing as in the previous review. It just gives it in a much nicer and a neater format. So you can see that this one is much higher publication quality. It offers a lot more customization as well. But you still get the same results, as in you get the numbers, you get the odds ratio there, the confidence interval, the weighting is the same, you get the p-value and the heterogeneity value, etc., etc. So there's two main methods. I think if you're starting first, just do the RevMan tutorial. And if you're not starting, if you feel like I'm pretty good at this and I actually like coding and want to challenge myself, then you can try it in R. You can also do things like look at the funnel plots in R. So just simply by typing funnel m.bin, which it's not specific as in just typing in funnel or going on to Google. If you run that with the same plot, you'll be able to identify a funnel plot as well. So with that, it's really helpful to just visualize all your plots in one, although it is a higher and much steeper learning curve. When RevMan, the program was around, it was very good and very easy to navigate. So if you can download the program as opposed to the web page, I would recommend it. But I do think the web page kind of ruins it a bit. So you're going to have to decide if you want to do meta-analysis for long term. You can either do it in RevMan or you can use another program. But I recommend one of these two. Once you get the crack on R, I think it's a really easy thing to do and it makes beautiful plots. For example, you have infinite customization here. So, I could just quite quickly change this to I think that should work. You can change the color of your plots. You can change pretty much any aspect of the plot. And you can also just quickly switch into random effects models as well and true and fixed effects depending on what you prefer. I think I should change it to yellow. Yeah. So really, those are the key things that you need to generate. Remember that our default is going to be random effects model, which we'll put in rather than a true effect. Heterogeneity is going to be 46%, so that justifies it's moderate, so it's low to moderate, so it justifies the decision to do random effects. And we can see we've just got a number of events and the total participants in each group, and the model just does the rest for us. And so really, meta-analysis can be done in approximately 2 or 3 minutes if you have the right data set, the right code, or just the right user interface. But it takes a lot of time and it takes a lot of skill to understand what you're doing and understand when is a good time. I think a lot of people just rush into meta-analysis and meta-analyze anything as soon as they get the code, but you do need to be aware of it, and you need to have a think about, is it the right time, and am I doing it correctly? Because some statisticians will really pull you up on this, and you just have to make sure what you've done is pretty sound methodologically, and that you could justify it if you had to speak to your senior about it or something to that effect. Right, so I think that's kind of the main section. What I would try and do in the interim is just give yourselves like sort of 8 to 10 minutes for general questions, because I think that's going to be more helpful as far as your specific questions for the projects. Obviously I can't use your screen, and I can't take 24 different people through how to use RevMan or how to use RStudio, but hopefully it kind of shows that, with a bit of a learning curve, you can do quite good meta-analysis and you can do good graphs. You just have to type in the data and have the right program. But yeah, that's pretty much the walking session. I'm aware there's a football match going on, so might be keen to watch that. But yeah, if anyone has any questions, I'll hang around for another couple of minutes. And yeah, if it happens to be relating to the reviews, that's great. If it's just general, I'm also happy to answer that as well. And that's all I've got for you today.
Yeah, I can't see any questions popping up just now, but I've seen you put your email in the chat earlier. So if they have any questions, they can reach out to you through your email. Yeah, is that okay?
Yeah, that's fine.
Yep.
That's fine. Yeah, so feel free to drop me an email, guys, and thank you for your time.
Well, thank you.
Of course. Bye.